Hello physics students, this video is to show you how to do your 3 calculations for the egg drop project. So our first calculation we need to do is the velocity of the egg right before it reaches the ground. So we can think like we have a ground state and then we're going to have an egg, and this egg is going to be dropped from some height. So we know the initial velocity of this egg will certainly be 0 because we're just going to drop it from rest. And then this egg is going to fall downwards, and then it's going to have some velocity that is not 0 right before it hits the ground. And that's the velocity that we are looking for. What is this velocity? So how can we do this? Well, we could actually do 2 different ways. We could look at this as a kinematics problem or a dynamics problem. I suggest, or not a dynamics problem, but an energy problem. Let's look at it from an energy point of view. That up here, we have some potential energy. And we know that that energy is going to be equal to mgh. And then down here, we have some kinetic energy. That potential that we had is going to 1/2 mv squared. My pen's not great. That potential energy that we had is going to go to 0, but all of it in turn is going to turn into kinetic energy. And that's going to be the way that we approach this problem. We can just set up an equation that says, well, the potential that we have at the beginning, mgh, that's going to be equal to the kinetic that we have at the end, which is 1/2 mv squared. Now, what are our values here? Well, that's going to depend on your problem. We can estimate a value for our mass of an egg. I can tell you just by looking up mass of egg. That a large grade A egg. It's going to be about, a mass of 0.56, so 0.57 kilograms. And that's a perfectly fine estimate to go with. That is a large grade A egg. Kind of depends on what size egg you use. Some eggs are medium, some are small, some are extra large. But the difference isn't really huge. They're all going to be around the same mass. It's going to be a pretty small mass. But if you take a look at our equation, that actually doesn't really matter for this problem, because what we have on both sides is mass. So we're going to put 0.057 on both sides, and we see that that just goes ahead and cancels out. Rearranging this equation a little bit for v squared, I would multiply both sides by 2, and I'd have 2gh is equal to v squared, or I could write that v is equal to the square root of 2gh. And that is how we are going to solve this problem. So we know 2g is just going to be equal to 9.8. So then we just have to ask ourselves, what is h? What are we going to plug in here? That's what height you dropped it from. I can't tell you what that is. You know what height you dropped it from. And all you need to do is estimate that. The important thing that we do is h is in meters. It has to be measured in meters. So if you dropped it from 6 feet, that is approximately 2 meters. Estimate, it does not need to be perfect. It just needs to be in the same ballpark. So estimate what your distance was in meters. You can do a conversion from feet to meters. It's a pretty easy conversion to do. Just estimate what yours was and then plug it into this equation. And then you got it. You know exactly what you need to do to solve for the velocity. And then keep that in. You're going to need to do that first because we're going to need this velocity v for the next problem. And so I'm going to clear out what we got here, because the next question asks us, what is the impulse that acts on the egg? Specifically, what is the impulse that acts on the egg when it comes to a stop? And so we can think about, well, right before it reaches the ground, we know we have some velocity v. Well, right after it reaches the ground, it's going to have a velocity of 0, because it's going to hit the ground and it's going to have a velocity, and then it's going to come to a stop. Impulse is just the change in momentum. And we know that's just final momentum minus initial momentum. And already we know our final momentum is going to be 0 because it comes to a stop. But right before it hits the ground, it's not at a stop. It has this velocity. So we can just plug this in then, that the minus the initial momentum. Initial momentum is just mass times the velocity that it had right before it hits the ground. We can just call that m times v. This v is the same as what we just solved for. As what we just solved for. It's that velocity right there, because right before, that's the velocity that it has, and then it comes to a stop. So we see already we're going to set ourselves up to have a negative impulse. That's great. The impulse is slowing the egg down. It is bringing it to a stop. And then the mass, if we do need a mass this time. Again, this is a mass for a large grade A egg. Yours might be a little higher, yours might be a little lower. You don't need to weigh an egg. I mean, if you have a device that can weigh such a small device, such a small item, go for it. You can weigh it, but this will be around the mass that you're going to need to use. And we do need to have that in kilograms. I looked it up, it was 57 grams, but you can convert that. So make sure yours is in kilograms as well. And then we just need to multiply that times our velocity. And then we have our impulse just by solving this equation right here and really just doing mass times velocity, seeing that that will be a negative value, which makes sense if we are slowing the egg down. So that was part 2, how to solve the impulse. All right, and then for our last time, the minimum impact time. So we are going to make use of the fact that impulse is related to the force times the displacement. Impulse is equal to force times the displacement. We just solved this. We solved same as what we just solved for. So we know what I is. And then it's just the question, we don't know what F or delta T is. And that's why I'm going to tell you, I'm going to give you the value of F. And what is this value? So this is the force that could be applied to your egg. And there's no way to say for sure exactly what your force is. But what I'm going to tell you is that the maximum, maximum force an egg can withstand without breaking. And I know what that is because we can just do a couple different experiments, and you don't need to do this one, but by testing, and this is obviously an average value, every egg is not going to be the same, but it's about 5.5 newtons. 5.5 newtons is the maximum force that an egg can withstand without breaking. So we're not asking for exactly what your impact time was. I'm asking for your minimum impact time. That at minimum, it must have come to a rest in this time, but it could have been a little bit longer. The exact values can vary, because remember, we are just multiplying this force times this time. The time is what we are trying to solve for. But if the force was a little bit smaller, our time would have been a little bit bigger, which is great. We know we want the force. The whole point of this design is to lower the force as much as possible and to increase the time as much as possible. If our force was any bigger than 5.5, then our egg most likely would have broken. So by putting that 5.5 in here, and since we know I, we can just divide here for delta t. That's just going to end up being delta t equals I over F. And then we can get around, this must have been at least how long it took. It could have, and then we know it could have taken longer, but that delta t will be the minimum impact time that we must have come to a stop with. All right, and again, we know I because we just solved it in the last part, and we're just going to plug in 5.5 for F because that's the maximum force an egg can withstand without breaking. And that is how you do all three of your calculations. If you have questions on any of these parts, you can always go back and pause the video, or please reach out and ask me. I'm always happy to help.